The James Webb Space Telescope, additionally known as JWST, is a scientific pioneer that has uncovered astonishing insights concerning stars, planets, worlds, and other interesting infinite peculiarities, as well as setting new norms for scientific energy. Webb is hailed as the admired Hubble Space Telescope's substitution. People from one side of the planet to the other are trading photographs and utilizing crude information to make new experiences. Join us on this astronomic journey. 3 minutes back, James Webb captured the most alarming picture ever seen in history. 1 year has passed since the considerable James Webb Space Telescope uncovered its very first memorable picture of the universe, stunning stargazers all across the world with its exceptional detail. Yet, its latest finding is an astonishing image of the universe that we have never seen before. What has been seen up to this point by the James Webb Space Telescope is suggesting more conversation starters than it deals with. Researchers consider it the replacement to the Hubble telescope, revealing new data about star development, universe consolidations, and the early universe. Just 1 month after the initial photographs were delivered, the photos were stunning, uncovering the universe in stunning detail. From that point forward, the quantity of revelations has soared, giving researchers a huge information treasure trove. James Webb Space Telescope's observations of grand tarantulas, record-breaking space smoke, stars on the verge of their cosmic explosion blasts, and other mind-blowing heavenly objects have been documented. This satellite observatory's state-of-the-art innovation permits us to peer farther into space than previously, uncovering previously obscure subtleties about the universe. A new era in cosmology has unfolded on account of the photographs, which are so detailed. To commemorate the first year of the James Webb Space Telescope's activity, NASA delivered a picture showing a small star-forming region in the Roochie Cloud Complex. The picture shows planes ejecting from infant stars as enormous dust billows of different colors and packed atomic hydrogen make up the red dust. The presence of a circumstellar circle causes some qualms about a few stars, suggesting the chance of planet formation. In the far-off past, the picture may show cosmic chaos, but according to NASA, this heavenly nursery is small and serene compared to others. Furthermore, many of the young stars in this region are about the size of our Sun or even significantly smaller, making it the closest star-forming area to Earth. This image was captured by the primary camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic images in 2 distinct infrared ranges simultaneously. Moreover, the Space Telescope has improved our understanding of exoplanets, or worlds that orbit stars other than our Sun. James Webb is particularly adept at examining large, distant worlds. The satellite observatory found its first exoplanet, LHS 475b, at the start of 2023. The planet is 41 light-years away and has a diameter equivalent to Earth's. James Webb, according to NASA, is the sole operational telescope capable of sequencing the air of Earth-sized exoplanets. The researchers responsible for the review group that made the discovery illustrated how precise the telescope was. Rough exoplanets are now a new frontier for stargazers to explore. After that, the James Webb Telescope found evidence of ancient galaxies that, from a theoretical perspective, shouldn't have existed. The lab of Swindon College and his overall galactic team had discovered 6 colossal old galaxies called universe breakers. They have the potential to fully impact the way we think about space. These gigantic universes might have appeared between 500 to 700 million years after the Big Bang, according to the researchers. Recently, the telescope's infrared sensors detected them. Through the utilization of these instruments, we can look back in time around 13.5 billion years, when stars and galaxies were much younger. The enormous size of the universe breakers has left researchers perplexed. Galaxies in the early universe ought to have been 10 to 100 times smaller than their calculations show. These 6 objects might be billions of times heavier than our Sun. The total mass of stars in one universe may be 100 billion times heavier than our Sun. The thought of trying to understand something so gigantic might give you chills. Despite technological advancements, planets that are quite large exist and have puzzled experts, none more so than the discovery of a planet considered excessively massive for its Sunday. This has prompted a reassessment of our collective understanding of planet formation and solar system engineering, as well as the models created by stargazers. A planet that is multiple times as massive as Earth has been found, according to research from Penn State. Legend has it that this planet is in a planetary system around the ultra-cool star LHS 3154, a star that is multiple times less massive than our Sun. Before recently seeing it for themselves, researchers didn't believe such a situation was possible, but new evidence shows that the largest planet in our solar system is orbiting one of the universe's smallest and coolest stars, an ultra-cool dwarf. We still have close to zero insight into the universe, and this finding demonstrates it even more. A planet of this mass orbiting a star with such a low mass defies our assumptions. These stars might have originated in massive gas and dust clouds. Planets may form from the gas and dust remaining in the material disk around the infant star. In this case, it wasn't expected that the planet-forming disks around the low-mass star LHS 3154 contained enough solid mass to produce this planet, but it exists. Thus, we must now reconsider our hypotheses regarding stellar and planetary development. A good comparison would be to contrast the star with a campfire. To keep warm, you must get closer to the fire as its temperature decreases. Planets are no different. Planets that need to be warm enough to support liquid water must be closer to their stars. You can use the inner planets of our solar system as a model to imagine how planets get hotter the closer they get to the star. For instance, our Earth is in the center of the habitable zone due to the water and warmth it receives from the Sun. The distances of other planets from our Sun are either too great or too small for them to receive the right amount of light to support life. Now, imagine a universe with an extremely cold star. Like moving closer to the campfire, you'd need to do the same with planets orbiting a cold star to get the ideal amount of heat to support life. The planet's radius should also be adjusted to give the right distance for heat and light to support life. Returning to our previous discussion, there are various theories about why the planet may have formed near this small star. According to a common belief, the planet might have been significantly larger before, but over time, it would have lost a substantial portion of its mass. However, this theory has a flaw because mass loss causes a planet to lose more gas than solids. In this scenario, most of the planet's mass would have been gaseous, which is inconsistent with the finding. Another theory is that this gigantic planet formed far from the tiny star. If the planet managed to maintain its distance from the low-mass star without receiving much light, it would likely be ice-covered. The star could eventually gravitationally attract this distant planet, resulting in this enormous planet being near this tiny star. Although there is a chance that both ideas could explain the observed planet and star pair, researchers are still unable to conclusively explain the phenomenon at this time. With cutting-edge advancements like JWST, scientists are now examining planetary systems in more detail, and each new discovery is pushing them further. We've learned more about how the universe has formed over the past few months than we have in the last 30 years. The vast amount of data the telescope provides has already led to significant scientific advances, amazing astronomers, and sparking interest in future space exploration. With the James Webb Space Telescope operating for a year now, one thing is certain: the universe is much more complex than we previously thought, and many questions remain unanswered. In addition to exoplanets, JWST has revolutionized our understanding of star formation and stellar evolution. Its ability to peer through dust clouds and observe star-forming regions in unprecedented detail has led to new insights into the processes by which stars are born and evolve over time. Beyond its specific discoveries, JWST has also raised new questions and opened avenues for further exploration. For example, its observations of distant galaxies and early universe structures have challenged existing theories about galaxy formation and the evolution of cosmic structures. The discovery of ancient massive galaxies known as universe breakers has prompted astronomers to reconsider their models of early galaxy evolution and the role of these galaxies in shaping the cosmos. Moreover, JWST's exploration of planetary systems has revealed unexpected diversity and complexity. The discovery of giant planets orbiting small, cool stars has defied conventional expectations about where and how planets can form. These findings have prompted astronomers to revise their theories of planetary formation and migration, shedding light on the processes that shape planetary systems across the universe. Looking ahead, JWST's continued operations promise even more discoveries and scientific breakthroughs. Its unique capabilities will allow astronomers to study the atmospheres of more exoplanets, unravel the mysteries of dark matter and dark energy, and explore the origins of life in the universe. Furthermore, JWST's observations will play a crucial role in preparing for future space exploration missions by providing detailed maps of cosmic environments and identifying potential targets of interest. JWST will guide the development of future telescopes and spacecraft aimed at exploring distant planets, moons, and asteroids. While JWST has faced technical challenges and delays throughout its development and deployment, its successful launch and early operational phase mark a triumph of international collaboration and perseverance in space exploration. The telescope's intricate systems and delicate instruments have required meticulous planning and execution by scientists, engineers, and mission controllers from NASA, ESA, and CSA. Each milestone achieved by JWST, from its initial light observations to its groundbreaking discoveries, represents a testament to human ingenuity and the quest for knowledge about our place in the universe. As JWST continues to operate and deliver unprecedented insights into the cosmos, it stands as a beacon of scientific progress and a symbol of humanity's enduring curiosity and exploratory spirit. In conclusion, the James Webb Space Telescope has already exceeded expectations and rewritten the textbooks of astronomy in its relatively short operational period. As it continues to collect data and make new discoveries, JWST will undoubtedly shape the future of astronomy and our understanding of the universe. With its advanced technology, unparalleled sensitivity, and ability to peer deeper into space and farther back in time than ever before, JWST promises to unlock countless mysteries of the cosmos and inspire future generations of scientists and explorers. As we await the next chapter in JWST's journey, one thing remains certain: the universe is vast, dynamic, and full of wonders waiting to be discovered. Through the lens of JWST, humanity stands poised on the threshold of a new era of cosmic exploration, where each observation brings us closer to unraveling the secrets of the universe and our place within it.